to introduce our current interim chairman, Dr. Frank Liu, to introduce our guest of honor. Frank?
Thank you very much. I'm very pleased to introduce John Lovett as a distinguished speaker tonight. He's a great supporter to the computer science department and the Missouri SNT, formerly UMR. You like UMR there, right?
Either way.
Yeah. John is going to share his career experience, insight, and vision with us. John started his career in computing in 1966. Wow, that's 47 years ago. That's almost my age, you know. I was born 62. Right, okay. Working as a part-time operator, a small engineering computer at the Beach Aircraft in Wichita, Kansas, while attending WSU, that's Wichita State University, right? In aeronautic engineering. The first step was learning Fortran from IBM program instruction menus. That's good because we still learn Fortran these days. Because many people say, oh gosh, I learned a lot of stuff, I never use it. All right. Let me see, okay. From IBM, okay, the menu, and debugging program in the evening so that engineers could get one more turn at correcting minor errors. This led to a full-time role in the aerodynamics department and a senior thesis of takeoff distance calculation program for jet aircraft. After graduation, he moved to St. Louis and McDonnell Douglas, where he did programming for flight simulators and operation research analysis, while completing a master's degree in computer science from UMR at St. Louis Extension. I taught there a couple of years, many years ago. The clear focus on software led him to move to HP, HP's newly established computer and automated testing area, as a field software engineer, working with customers to apply and use the products effectively, and eventually to sales and the technical and the sales management. In 1986, he left HP to join Rational Software, which was a tiny company at the time. I think this is a great step for you personally, though. And continued there as a senior executive responsible for all customer-related activity worldwide until the sales to IBM in 2003. Is that $2 billion transaction? Yes. That's how big the company is. Okay. This process of building Rational into the world's largest and most successful software development product and process company gave him inside seat in the evolving software market. Since retiring after the IBM acquisition, he has been active with nonprofit work in health, housing, international leadership development, and economic development around the world, as well as a board member and advisor to many tech startups in various fields, most particularly in biomedical analysis and personalized medicine. He also spent 3 years as CEO of Patent Insight, a software startup in code and log analysis. This long view of industry from the inside has given John an interesting perspective on the past and some opinions about the future he would like to share, hopefully for your benefit in shaping your own career. Here's the John. Let's welcome John.
Thanks, Frank. It has been a long and a very interesting view of computing, but I think what I went through in that period is only the very beginning of what I think you guys are going to have a chance to go through as you start your careers now in computing. And I'd like to share a few thoughts about what kinds of things are happening or have happened and are going to be happening that I think maybe, hopefully, will be useful for you. So So first of all, I think he chose very wisely to be in computer science in today's world. It's, I think, by far the best career and has all kind of opportunities in front of it. I think it is going to be interesting, though, that it's going to be an evolution. And part of the evolution that I've seen through the companies that were the biggest and the most successful companies as I was going along in my career started with IBM. And IBM was a computer company. It wasn't a software company, it wasn't a services company, it was a computer company. You know, the next step was the software companies, and Oracle is a classic case of a very successful all software company. Never any hardware in their portfolio until they bought Sun, I guess. But they made their business around software specifically. Now, you know, I may get disagreement, but hopefully agreement from the Google folks and probably from the TradeBot people that you're knowledge companies. The software is an enabling technology, but the real key is knowledge that you've been able to capture and encode and apply with that. And I think that's where there's going to be a huge future, is computer science as applied to various application domains and various knowledge domains. And so I think that's going to be important, but I think what's going to happen is it's going to change from being programming computer science oriented thing to being knowledge. And really, I think if you start thinking about yourselves as knowledge engineers, you'll set a broader view of what it is that the business of software enables you to do. Now, it's not going to only be, though, that you're going to do that, but it's going to change the way you're going to have to interact with the application domain. And you know, in my career, I think I was fortunate because I got started in the application domain of aeronautical engineering more than in the computer science part. So I've always had an affinity for the application side as well. But what's going to happen is that as software is used to be the next form of knowledge capture, it's got one big advantage over the previous mechanism, which is you can apply the knowledge real time. And TradeBot's a classic example of that, right? You basically have knowledge, and it's actionable knowledge, and it's encoded in the software. To do that, you've got to really understand the domain that you're working with and what the ins and outs and the issues are with the domain. And that's where, you know, the experience that I've had recently working with medical analytics companies exposes both the opportunity in terms of new forms of knowledge that can be potentially very valuable, but also some of the problems and deficiencies in the stack of capability that's been built up by computer science. So a lot of the knowledge in computer science has been built around business applications, which are very mature. And it is kind of interesting that business applications and accounting work started being done in the 50s, I guess. But it was 1970, mid-70s, when the relational database was created. So there were 20 or 30 years there of domain experience before the tool that's the most relevant and pertinent tool for that application domain was created by computer science. So I think it's going to be an interesting phase of application of new domains, and a lot of the challenges we had of computer people talking to domain people and understanding that, and understanding how the tools that you're trying to use that came from another domain, which right now the relational database is being applied to a lot of stuff in medical analytics, part of which it's very appropriate for, and a large part of which are just fundamentally different data structures. And so somewhere along the line there'll be the equivalent of the relational database for more biological information. I think looking at what Google did in terms of accessing knowledge on the web, you have very different data structures. So if you try to apply the same computing principles and data structures to web search, you just didn't get there. So I think there's going to be a lot of that. But also software, because once it's developed, it's free to replicate. And because you can get groups together, like put Android together or put other things together, it's got different kind of economics. But some of those, I think, are relevant as you look at new application areas. So, first of all, in the time I've been in the business, the biggest thing I've seen, even with all of the work we did in software development tools and object-oriented structures and so on is the ability to abstract. So, for me, that reusability and abstraction first came using atmospheric tables that were there and having a compiler. So, but what's happened is every evolution has created more layers of abstraction, which allows the application domain people to get access to all the tools that have been created over the years. So that abstraction capability is unique among knowledge techniques also. So it's not just that you've got an abstraction that represents something, it represents something that's useful and actionable. And by the time you get to the application layer, so with an Android phone or an iPhone, you've got decades of knowledge that's been accumulated in an actionable form that you get to build on top of. So one of the things that does is it eliminates a lot of complexity limits that you had around developing a whole system top to bottom. So the complexity constraints are going away, which is a good thing because the data available is becoming more and more and more complex, and different data structures with high dependencies, with irregular population of the data structures. So a medical health record is problematic because it's got a time dimension, which is very important, and it's also not consistently populated. So different people have different problems, and the data structures that need to go with that are different. But in the end, what's going to happen is that software is going to be applicable to virtually all data domains. And right now, it's already in delivery, so you almost can't get to knowledge without having software touch it on the way. But more and more, it's becoming encoded in it. But I think the implications on that is that the tools are going to need to, the deep computer science tools are going to need to evolve to match the domains and the data structures that are appropriate for those domains. And a lot of those are heterogeneous domains. So for medical, for example, not only is it problematic that the relational database doesn't fit everything, but the other data can be image data, it can be analog data, it can be anecdotal data. So so you've got a wide variety of data forms. And right now, the tools to put those all together and get meaning out of them are still part of what's in development. So those of you that stay deep in computer science, you're going to get a chance to do some really interesting work around that. So that's part of the challenges that's going to come with new skills that are going to have to be there. And I think some of those are, already the ability to leverage existing software is just huge. So the Pattern Insight, the company I was at, had basically a 2 million line of code product, of which about 50,000 lines was our code. All the rest of it was stuff